So in this video, we're going to use Laplace transform to solve for x double prime minus 7x prime plus 6x is equal to e to the t plus Dirac delta of t minus 2 plus Dirac delta of t minus 4. Given the initial conditions x of 0 is equal to 0 and x prime of 0 is equal to 0. Now take note that this notation here, x double dot above, is just equivalent to x double prime, and this x with one dot above is just equivalent to x prime. So we call it x double prime, and this one we call it x prime. Okay, so those are just the same things. So let's go write our differential equation. X double prime minus 7x prime plus 6x is equal to e to the t plus Dirac delta of t minus 2 plus Dirac delta of t minus 4. So first thing we're going to do again is take the Laplace transform of both sides of the equation by linearity. So again, take the Laplace transform of the left-hand side of the equation. Laplace transform of x double prime minus 7x prime plus 6x is equal to, take the Laplace transform of the right-hand side, Laplace transform of e to the t plus Dirac delta of t minus 2 plus Dirac delta of t minus 4. Okay, so take the Laplace transform of this left-hand side by linearity. We can actually write this as like this: Laplace transform of x double prime minus 7, because this is constant, Laplace transform of x prime plus 6 Laplace of x is equal to Laplace of e to the t plus Dirac delta of t minus 2 plus Dirac delta of t minus 4. So now let's take the Laplace of x double prime. The Laplace of x double prime is just s squared x of s. Take note that your x when you're in s domain should be in uppercase. So this x here is in uppercase. Minus s x of 0, that's in lowercase because this is the initial condition, x of 0 minus x prime of 0. This is the initial condition 2 minus, let's go 7 because this is 7. The Laplace transform of x prime is x of s minus x of 0. And then we'll go write this one plus 6. The Laplace transform of x is obviously the uppercase x of s is equal to the Laplace transform of e to the t plus the Laplace transform of Dirac delta of t minus 2 plus the Laplace transform of Dirac delta t minus 4. Okay, so since our initial conditions are x of 0 is equal to 0 and x prime of 0 is 0, so we can actually cancel these things here. X of 0 is just 0, x prime of 0 is just 0, x of 0 is 0. So those are the things that are cancelled. So we're going to write s squared here. And we can actually combine this one. Negative 7 times s is just minus 7s xs plus 6xs, which is equal to the Laplace of e to the t plus Laplace of Dirac delta t minus 2 plus the Laplace of Dirac delta t minus 4. Let's go solve for the Laplace of the right-hand side of our equation. And take note also that we should expect this answer here. Number 5 answer. Okay? This answer is given, so we should have the same answer exactly as this one. Let's just go take the Laplace of e to the t. What's the Laplace of e to the t? Let's go have a review with the Laplace transforms. We have a formula here, and we're going to use this one. The Laplace transform of this function, e to the at, where a is constant, is just 1 over s minus a. So let's go back to that one. So what is our a? Our a is just 1, right? So the Laplace transform of e to the 1t is just 1 over s minus a. A is 1, so that's 1 over s minus 1. How about the Laplace transform of Dirac delta? I've derived the Laplace of Dirac delta in my other video, so just see those other video. We'll just do formulas here in this video, so we're not going to tackle about how we derive the Laplace of the Dirac delta function. So we'll just go see the formula, the Laplace of the Dirac delta. Let's go here. So this one is our formula for the this is our Dirac delta function, and its Laplace transform is e to the, if our Dirac delta is Dirac delta of t minus c, where c is constant, the Laplace transform of this Dirac delta function is e to the negative cs. So we use c here. So whatever is written in here as constant c, we put it in here. So just like remember e to the negative cs. That's the formula, e to the negative cs. So what's our c here? Our c is 2, right? Our c is 2, so we can actually say that the Laplace transform of the Dirac delta of t minus 2 is just e to the negative 2s, right? That's negative 2s because our c is 2, so we just plug in here. Now we have a Laplace transform of e to the negative 2s. How about the Laplace transform of the Dirac delta of t minus 4? That's just e to the, our c is 4, so that we plug in that c here, e to the negative cs, where c is 4, so our answer is e to the negative 4s. Okay, so I'll copy these things here in the right hand side of the equation. Let's go copy this one. The Laplace of e to the t is 1 over s minus 1 plus the Laplace of Dirac delta of t minus 2 is e to the negative 2s. The Laplace transform of Dirac delta of t minus 4 is e to the negative 4s. So that's it. And we can factor these things out. The excess, s squared minus 7s plus 6. Factor out the xs. So now we'll get the function, our function x of s. So our function of x of s, divide both sides of the equation by s squared minus 7s plus 6. Our answer is just this one. 1 over s minus 1 plus e to the negative 2s plus e to the negative 4s all over s squared minus 7s plus 6. So let's go split those up. So we'll have 1 over s minus 1 times 1 over s squared minus 7s plus 6 plus e to the negative 2s plus e to the negative 4s all over s squared minus 7s plus 6. So I wanted to split these two here, or split this function right here, because I want to have, because we will have a different partial fraction decomposition. If we factor out s squared minus 7s plus 6, that would be s minus 1, s minus 6, right? So this is the factor form of s squared minus 7s plus 6. So our x's now will be 1 over s minus 1 times 1 over s minus 1 times s minus 6 plus e to the negative 2s plus e to the negative 4s all over s squared minus 7s plus 6. Oh no, we'll go write the factored form, s minus 1, s minus 6. And we'll go look for the partial fraction decomposition. 1 over s minus 1, partial fraction decomposition. So we can actually temporarily forget about this one here, this expression e to the negative 2s plus e to the negative 4s, and we're gonna deal first with 1 over s minus 1 times s minus 6. The form that is similar to that one is this one, right? We have two factors, which is x minus a times x minus b. And as you notice, we have s minus 1 times s minus 6. It's just the same form, only this one is in x. This one is in terms of x. So we're gonna go use this first. We'll go that form of partial fraction. Let's go split this into 2. We'll go write a here, and we'll go use the first factor, which is s minus 1 plus b over s minus 6. Okay, so the next thing we're going to do is multiply both sides of the equation by the denominator here, so that the left hand side of the equation will become 1. So this is 1, right? Because 1 over s minus 1 times s minus 6 times s minus 1 times s minus 6, we just cancel these out, but we would not do that. So that's just 1 here times a. When this one here is multiplied here, what's cancelled? S minus 1, okay? So we'd be left with s minus 6 plus b. If this one is multiplied to this one, what's cancelled is s minus 6, so we'd be left with b times s minus 1. The next thing we're going to do is to look for the value of a and b, so that we'll have a partial fraction decomposition. So to solve for a, let's just go set a value where this term here will be 0. So what is the value of s that will make this term 0? If s is equal to 1, right? If s is equal to 1, this would be 0 completely. So copy this one here. A times s is 1, 1 minus 6, plus b, 1 minus 1. So this would be 0. And that would be 1 minus 6, negative 5. Divide both sides by negative 5. So our a is negative 1/5. So how about we solve for our b? We solve for our b. What makes this term 0? If we set s is equal to 6. So if s is equal to 6, this would be a times 6 minus 6. This will eventually turn to 0. Plus b, 6 minus 1 is just 5, right? But we'll go write it down to be clear. 1 is equal to b times 5 divided by 5. So b now is 1/5. So we have a partial fraction decomposition of this function here, which is a is negative 1/5 over s minus 1, and b here is 1/5 over s minus 6. So remember this. Let's go take the partial fraction decomposition of this one here. Let's go write that down. And there is an extra s minus 1. So let's go 1 over s minus 1 times s minus 1 times s minus 6. So let's go look for our patterns. What patterns can we use here? So take note that we have like this pattern here, right? Because we have 2x s minus 1 and we only have 1 s minus 6. So we're gonna go use this pattern, because this one here can be expressed into 1 over s minus 1 squared times s minus 6. And this is like this form. This one here is like this form. This one here. S minus 1 squared times s minus 6. So I'll go use this one. First term, we have s minus 1, right? And second term, we have s minus 1 raised to squared. And third term, we have s minus 6. let's go have a over s minus 1 plus b over s minus 1 raised to 2 plus c over s minus 6. Okay, so next thing we're gonna do is multiply both sides of the equation by this one here, by the denominator. So let's just go use s minus 1 squared, s minus 6. Okay, so 1 over s minus 1 squared times s minus 6 times, if we multiply this here, what do we get? 1, right? So we'll just get 1 from in here, left hand side of the equation. And if we multiply this one here, we'll go get 8 times. We can cancel s minus 1, so we'd be left with s minus 1 times s minus 6. Plus, if we multiply this term here to this here, we cancel s minus 1 squared, and we'd be left with b times s minus 6. Plus, if we multiply this one here to here, we cancel s minus 6, so we'll be left with c times s minus 1 squared. So let's go look for the values of a, b, and c by setting values for our s. So let's just go think of, say, s is equal to 6. So s is equal to 6. I selected this one because I wanted this term here and this term here to be 0. So we'll go look for c. 1 is equal to, this would be 0, and this would be 0. So 0 plus 0 plus c, 6 minus 1 squared, so that would be 5 squared, right? 6 minus 1 is 5, so let's just go right 25, because 5 squared is 25. And let's go divide by 25, and we'll have now c is equal to 1 over 25. How about if we set s is equal to 1? So this would be 1 is equal to, this term here would be 0. So we'd have 0. This one here would not be 0. That would be 1 minus 6. 1 minus 6, that would be negative 5. Let's just go right negative 5 to save up space. Plus c times 1 minus 1 is 0. So that's just 0. And our b now is, we just divide by negative 5 both sides of the equation. So we'd have negative 1/5 for our b. Okay, for our a, we just said, so we've already used the 6 and the 1 to make the other terms 0, so we just use s is equal to 0. If s is 0, this is 1 is equal to a times 0 minus 1 is negative 1, 0 minus 6 is negative 6, plus b times 0 minus 6 is negative 6, plus c times 0 minus 1 is negative 1 squared. So this is just 1, so we just put it like that one. And we plug in the values of b and c to look for the a. 1 is equal to a times negative 1 times negative 6 is just 6, plus b is now negative 1/5. So negative 1/5 times negative 6 is just 6 over 5. And your c is just 1 over 25. And we'll go multiply both sides by 25. So we'll have 1 times 25 is equal to 25 times 6 is 150, right? Because 25 times 4 is 100, and the remaining 2 times 25 is 50, that's 150. Plus 25 times 6 over 5, 25 over 5 is 5 times 6 is 30, plus 25 over 25 is just 1. So 150a is equal to 25. We'll go move these 30 and 1 to the left hand side of the equation. That is minus 30 minus 1. So we'd have minus 5 minus 1 is equal to minus 6, right? Minus 6. So divide both sides of the equation by 150. So we'll go have our a. So we can actually reduce this to lowest terms. Divide this one by 3. We'll have divide by 3, divide by 3, we'll have negative 2 over 50. But we can still divide it by 2. Divide by 2, divide by 2, that's negative 1 over 25. So our A now is negative 1 over 25. 1 over s minus 1 squared times s minus 6 is equal to A is negative 1 over 25 all over s minus 1 plus our B is, what is our B? Our B is negative 1/5. So our B is negative 1/5. Negative 1/5 over s minus 1. Remember that this one here is squared. Make sure to not interchange these values because it will be a different partial fraction decomposition if you interchange these a, b, or c, and so on. Plus c. Our c is 1 over 25. Our c is 1 over 25, and that's just s minus 6. So now we have a partial fraction decomposition of this one, and we can now easily get our inverse Laplace once we get these partial fraction decomposition. So let's go back with these here. Our original x of s is these. So I'll just copy this. So we'll have x of s is equal to, the partial fraction decomposition of this one is just this one. So we'll copy that one here. Negative 1 over 25 over s minus 1 plus negative 1/5 all over s minus 1 squared plus 1 over 25 s minus 6. So how about this one? Let's go back. Let's go see the partial fraction decomposition. So this is our partial. Let's just go copy this. Let's just go copy this one. Bring it here. Okay. So we now have, but take note that we still have this term here, so we don't forget about that. Well, we're gonna use, or we're gonna write it down here, e to the negative 2s plus e to the negative 4s. Okay, now it's time to solve for our x of t, our explicit solution, which is just the inverse Laplace of the x of s. So Laplace is just linear, so we can write it as this one. The Laplace of negative 1 over 25 over s minus 1 plus the Laplace of negative 1 over 5 over s minus 1 squared plus the Laplace of 1 over 25 over s minus 6 plus the Laplace of this one here, negative 1/5 over s minus 1 plus 1/5 s minus 6 times, don't forget this, negative 2s plus e to the negative 4s. Let's go have a review with the inverse Laplace. The inverse Laplace, let's go with the formula. Where was that? Let's go with the formula. So if the Laplace transform of e to the at is just 1 over s minus a, so that means the inverse Laplace transform of 1 over s minus a is just e to the at. Right? So remember that one. We're also going to use this formula here because we have a factor s minus 1 squared, right? So this one here, we're going to use this. And we're going to use this. But let's just go back there later. So this one here is just, we can actually factor out the constant, which is negative 1 over 25. So we'll now have Laplace of 1 over s minus 1. It's just e to the a. Our a is 1, so e to the t. This one is this form. This one is this form here. The Laplace transform of n factorial over s minus a to the n plus 1 is just this one. T to the n, e to the at. So let's go write that down. where n is equal to 1, 2, 3, whole numbers. N is whole numbers. Inverse Laplace of, is it n factorial over s minus 1 to the n plus 1 is equal to t to the n e to the at. This one is a e to the at. So this one here, if this is our term, so we can actually express this as, say we took out the negative 1/5 and we'll be left with the Laplace transform of just 1 over s minus 1 squared. So we can actually express this into this form. So that is 1 factorial over s minus 1 to the, our n plus 1 is 2. So that's why our n is 1 plus 1. Okay? Our n is 1 because our n plus 1 is 2. Okay? So we put 1 here. So that's t to the, our n is 1, so we can actually write t alone. E to the, our a is 1, so we can actually write e to the t. Okay? So we can actually change this to t e to the t. Remember this one, because we would not want it. And we can actually move out the 1 over 25 here, and again s minus 6, it's just the same here, but our a now is 6, so that's e to the 6t. How about this one here? This one here we haven't solved yet, so let's go back with a formula here. So basically we just use this Heaviside function here. Heaviside function uc of t, f of t minus c. The Laplace transform of this one is e to the negative cs f of s. So we can actually do the vice versa, taking the inverse Laplace. So I just copy this one here. We can actually distribute this one because we're gonna use only one term at a time. The Laplace of negative 1/5 s minus 1 plus 1/5 over s minus 6 times e to the negative 2s. Okay, and also here, this one is plus Laplace negative 1/5 over s minus 1 plus 1/5 over s minus 6 e to the negative 4s. Okay, so let's go deal with this one first here. This one, let's go deal with this one first. Our e to the, let's go make this in this form, e to the negative 2s, so that you'll see what is the value of c. And our f of s is actually this one, negative 1/5 over s minus 1 plus 1/5 s minus 6. Okay, so the inverse Laplace of this one, this is inverse Laplace, this is inverse Laplace. So the inverse Laplace of this one here is just u, or the unit step. This is the unit step function. The unit step function sub c. Our c is, can you notice that c is 2? So we'll write 2 here of t, f of t minus 2. But our f of t minus 2 would be, f of t minus t would be e to the t minus 2, right? Because this is our f of s. If this is our f of s, this is our f of s, 1 over s minus 1. Our f of t is actually e to the t, right? But it says in here that it should be f of t minus 2. So we just replace with the t with t minus 2. And the constant, we actually move it out. So that's it. So that's e to the t minus 2. That's unit step function. So this is only one part. Since we have a constant here, we also write minus 1/5. So basically, this inverse Laplace is only the answer for this one. We haven't actually solved for this one yet. Let's go with that. If our f of s, say, is 1 over s minus 6, our f of t, remember, is e to the 6t. So our f of t minus 2 is e to the 6t minus 2. So we'll write it down here. We'll just do the same thing. We'll have 1/5 u of our c. Since our c is 2, we'll write to here e to the, but this time it is this one here, e to the 6t minus 2. So this one here is the answer for this one, the inverse Laplace of this one, only this part. So this would be basically negative. Let's just copy 1 over 25 e to the t minus 1/5 t e to the t plus 1 over 25 e to the 6t, and we'll just go copy this one. This is just this first part here, plus we can move this u of 2t, u sub 2t out, or we can actually write a stepped t minus 2. We can write it that in that notation. So that's negative 1/5 e to the t minus 2 plus 1/5 e to the 6t minus 2 with our step function stepped t minus 2. So step t minus 2 is just the same as this one. We just denote it in different ways so that will be identical with the given answer. So how about this one? We haven't answered this one yet. Our c now will become 4. So we just change the constant c here. So we can actually write the same thing, negative 1/5 e to the t minus, this one here is 2, right? So we change it to 4 because the only difference between these two is 2 and 4, so we change it to 4. This here, this 2 here, 2 here, 2 here, we change it to 4. So we'll just copy the same thing, e to the 6 t minus 4, where stepped is t minus 4. Okay, let's go see if we have the same answer with the given answer. So our answer is this. Compare this one here. Let's go compare our answer. This one here is this one, right? Correct? That's correct. This one here is this one, correct? Negative 1/50 e to the t. This one here is this one, 1 over 25 e to the 60. And this one here, negative 1/5 e to the t minus 2 is this one. And this one here, 1/5 e to the 6 times t minus 2 is this one here. That's correct. And step t minus 2, that's correct. Negative 1/5 e to the t minus 4, this is that one, correct. Plus 1/5 e to the 6 t minus 4, that's here, that's correct. And stepped t minus 4, that's here. So our answer is actually the same given answer. So we can conclude that we did the right solution. Thank you for watching my video.